One, two, three. Three of you are there. Wait for 2, 3 more minutes, people. Let everybody join. Then we'll start. So, guys, I think some of you had exams, right? Midterm or something, isn't it?
Yes, sir.
How was it? Was it good? Was it really do good?
It was good, sir. Not too easy, not too difficult.
How was chemistry, especially?
Same, sir.
Okay. Okay. So it's almost 7:06, and yeah, and almost everyone is there. Cool. So we can start, right? So, people, right? So we have been seeing thermodynamics. And all know that last class we saw for different processes, for different types of process, right? How the first law will change, how the first law will change in the sense how the equation of first law will change, right? So for an adiabatic, for a isothermal process, for a sorry, for an isobaric process, for an isochoric process, right? An adiabatic process. All these things we saw how my mathematical form of first law changes, right? And then we went on to derive an important equation for isothermal reversible expansion of an ideal gas, right? Okay. Now let me ask you some questions regarding last class, right? So tell me, people, right? What do you mean? How will you define delta E? Change in internal energy. How will you define it, and what is the formula for it? You can answer my question. I'm asking, how do you define delta E? I know the definition is like not the definition which we saw earlier from last class, right? What is the definition which I gave you for delta E, and what is the formula for delta E? Okay. So I mean, like all of you are quiet. That means I think you don't know. Let me give you a clue. Right. So it's something to do regarding with your isochoric process. So again, second clue. It has something to do with the heat during an isochoric process. Keeping quiet is not gonna help. I'm more of a peaceful guy, right? I can keep quiet. I can just look at the screen for the entire 1 hour.
Sir,
Tell
I
me.
just joined. Could you repeat the question?
Okay. So what I'm asking is, from last class, how did we define change in internal energy, and what was the formula?
The Q plus W, sir.
Delta E is equal to Q plus W, I know, right? But we derived a formula for delta E exclusively, and we defined delta E, and I gave clue as it is something has something regarding something to do with your isochoric process.
N into CV into change in temperature.
Okay, so fine. So that's the formula. Delta E is equal to NCV del T. Right? Hope you all remember this. Right? Okay. Like this? Okay, fine. How do we define delta E? How did I arrive at this equation?
We found out the value of Q first.
Q. Okay, we don't have to find the value. I have an equation for Q. What was the equation for Q?
NCV del T plus NCP del T.
Good, right? So Q is equal to NCV del T plus NCP del T. This was the overall equation. Okay. So from this, how did we end up with delta E is equal to NCV del T?
Since this is an isochoric process, constant volume is there. So we took NCV del T and we excluded NCP del T.
Okay, fine. So people, this is how I define my delta E, right? Delta E is equal to, delta E is the heat added or heat lost at constant volume. So this is how, so if you can go for an isochoric process, right? I know how the equation will change. Delta E is equal to Q plus W, and I know W is minus P external del V. And if it's an isochoric process, I know delta V is 0, so W is 0. So I can write that as QV is equal to delta E. And what is this QV? QV is the heat lost or heat gained at constant volume. And that is what is equal to my delta E. And obviously, if I go to this equation, if I put QV, this has no role to play. So only this stays. So QV delta E will be equal to NCV del T. Okay, fine. I think I'm gonna pick a person. It's not gonna work. Let me ask Abhishek. Are you there, Abhishek?
Yes, sir.
Kana, can you tell me what will be the same way we went for an isobaric process?
Sir, your video
Yeah.
stuck. Sir.
It's okay because I'm looking at the chat. I mean, I'm looking at the what is that? Now I think it will be fine. So, anyways, so I'm asking. I mean, we talked about isobaric process, right? So I introduced you to a new term there. What was it? New thermodynamic term there.
Enthalpy.
Good. Okay, fine. Thank you, Abhishek.
Sir, it was not me, sir. It was some other person.
Oh, fine. I don't know who was that.
No.
Rahul.
Oh, Rahul. Okay, Rahul. You'll fine. Anyways, now I'll ask you one more question. Then, if that's the case, fine. So it is enthalpy. Okay, correct. Now, how did they define my enthalpy, Abhishek? Okay. What was the what is that the symbol for enthalpy?
Sir, delta, sir.
Delta. No problem, Abhishek. Okay, so since Rahul, you were so interested, tell me what was the symbol for enthalpy?
Sir, repeat, sir.
I'm asking you, I'm asking what was the symbol for enthalpy, change in enthalpy?
Delta H.
Yeah, good, delta H. Okay, fine. Now one more question for you. Well, how did we define this? How did we define delta H?
Gain or loss of heat at constant temperature. Constant pressure.
Yes.
Constant pressure.
Yes, Rahul, correct. Right. So we defined delta H as the heat lost or heat gained at constant pressure. Right. So obviously now I'll be getting an equation like just like how I did for delta E. That was happening in constant volume. Now delta H is going to happen at constant pressure. So CV del T will have no role to play. I can write delta H as NCT del T. Right? Okay, fine. Okay, let me catch another person. Whom should I ask? Okay. Surya, are you there? Surya?
Yes, sir.
Ankana. We went for an isothermal process, isn't it? Right. So can you tell me how the mathematical form of first law will look for an isothermal process? So I have this delta E is equal to Q plus W, but this is not going to be the way that I'm going to write for isothermal. What it will be? Okay, it's better, right? So, okay, are you able to see my board?
Yes, sir.
Yes, sir.
Okay, I know there's little glare, but still it will come back in 2-3 minutes, and we'll go for it. Anyways, so yeah, Surya, what is the answer? How this thing will look? The equation will look? Oh, Surya is there.
I'm there, sir. I just don't know.
Okay, no problem. Fine. So then let me ask. Okay, Venisha is absent today. Fine. Pranav, are you there, Pranav?
Sir, even I am sure, sir.
Even you don't know?
Yeah, sir.
Okay, fine. Shruti, can you tell me, Shruti?
Yes, W equal to
Hmm.
2.303.
No. Yeah, correct. That is the overall. That's about an isothermal reversible expansion
Sir,
of an
is
ideal
it
gas.
Q is equal to minus W?
Okay. Yes. So it's Q is equal to minus W. Okay. Now, how did we end up with this equation? Is very simple. So because I know delta E is equal to Q plus W and delta E is NCV del T, and since it is isothermal, that is no change in temperature, this is 0. So we'll be ending up with this equation. Right? And yeah, Shruti, we can continue with this reversible isothermal expansion of a gas. What is the equation, Shruti?
2.303 nRT log of V1 by root 2.
V1 by?
V1 by root 2. V2, sir. Sorry.
Okay. Yeah, V1 by V2. Yes, correct. Right. So this is especially for the work done during an isothermal reversible expansion of a gas, ideal gas especially, right? So this is where we stopped last class. Okay, fine. Let me just finish up my adiabatic process, and then we'll do a lot of problems. Okay, fine. Or I might be asking you questions like this for this entire chapter. Right, cool. Right, so we'll go for adiabatic process. Right, so I know what happens in an adiabatic process, isn't it? There is no heat lost or there is no heat gained during the process, right? So if I write my first law of thermodynamics mathematical equation, right? So delta E is equal to Q plus W. So I know in this case, Q is 0. There will not be any heat gained or heat lost. So I can directly write delta E is equal to W. Okay, now this is a simple adiabatic process. It might be a reversible process or it might be a irreversible process. Correct. So now what we'll do is we will take a reversible case, right? So we are going for adiabatic reversible expansion of an ideal gas again, right? Just like how we did last time for isothermal, right? So we will be doing it for adiabatic reversible expansion of an ideal gas. Okay, so we will start with this only, people. I have delta. So we know the equation. How is it going to look for an adiabatic process? Delta E is equal to W. This we know, right? Now, since it is going to be a reversible process, right? I know the changes are going to happen very, very slowly in very, very small steps, isn't it? So I know the equation for your delta E, right? So it is going to be NCV. Now, instead of writing del T, because del T is a very large change, but what I can do is for a very small change, I'll write it as dt. Okay, NCV dt I'll write instead of del T, because dt is the small change in temperature. Okay, now for W also I can write it as minus P external dV. Again, small change in volume because we're talking about reversible expansion of a gas. Okay, so obviously if at all I want to get the overall thing out, right? Okay, current came through. 1 second. Oops. Yeah, so continuing, I think now there is no glare, nothing, right? Okay, so if at all I want to get the overall thing out, I have to integrate obviously, right? But I cannot directly integrate it, right? Like you have to do certain small things, then we'll integrate. Okay, fine. So now what we'll do is, now I'll keep NCV del T here only. NCV now what is going to happen? I can write it as minus nRT divided by V d. No issues, right? Okay, continue.
Sir, doubt, sir. 1 minute,
Yeah.
sir.
Yeah.
Your screen froze for me for some time, sir. Could you repeat the last?
Sure. So we just arrived at this equation for any adiabatic process. Delta E is equal to W because Q is 0, right? So now I know the equation for delta E. Delta E is NCV del T, but since we're talking about a reversible process, I'll take a very small change that will become dt, right? Same way for work, it is minus P external del D, but again, reversible process, I write dV. That's it. Now what I did is, instead of P external, I used my ideal gas equation to write P as nRT by V. That's what I did, right?
Okay, sir.
Yeah, now we'll continue. Now what I'll do is, See, dv by v is here. Basically, dv and v are in the same side. So I should have dt and t also to be in the same side for me to integrate it. Right, definitely. Now, last case, in an isothermal process, right, I didn't have anything to do with T because T was not changing, right? But here, temperature might or might not change. So we don't know that. So definitely, I have to include it in the picture, right? So now, again, I can cancel n and n. Number of moles gets cancelled, right? So now I have, say, Cv by T dt is equal to minus R by V dV. This is what I have. Anything else I missed? Nothing. Right? Now I can integrate it. Right? So obviously I have to put the limits properly. Say initial temperature T1 to final temperature T2. Say initial volume V1 to final volume V2. Right? Okay. Fine. Now I know CV is a constant. R is a constant. So I can actually take it out. Right? So I can write it as, now I know, okay. Now tell me, what is dt by t? Integration. dt by t integration or dv by v integration is equal to what? Last class we did, right? For isothermal process. What happened there? dv by v. What did he do?
Becomes log, sir.
Correct. Right? So whenever I have this dx by x, please understand dx by x is ln x. Like I cannot write log, I can write, no problem. But it is ln means log to the base e. That's what we need to know. Okay, fine. So I have dt by t, so it will become cv log or ln t, and I have the limits from t1 to t2, and here I would have had minus r log v. Again, I have the limits. I have the limits to become v1 to v2. No problem. Okay, fine. Now what I have to do? I have to substitute the limits, right? Now generally what we do upper limit minus lower limit, correct? So if I write upper limit log t2 minus log of t1, I know log a minus log b will become log of a by b, right? So all these things I can put here. So I can write cv into log of t2 by t1. Guys, hope you understand how I got this. I just put t2 log of t2. I'll put t1 minus log of t1. Log a minus log b will become log of a by b. That's what I did here. Is equal to minus r into log. Now, if I don't want this minus sign, right? So what I can do is I can just put the multiplied inside. I can write it as lower limit minus upper limit, right? So in that case, I'll be getting v1 by v2. Yes. Okay. Right. So next. Okay. So I have. Okay. Now I can write it like this. CV by R, if I bring it here. Okay. Now what I'm gonna do is actually I'm gonna take, see, I'm going to use this. Basically, I have a log of b. Generally, how will it be? It will be basically, it would have come like the b, it would have been log of b power a. Only then I'll be able to write it as a log b. The power will come to the multiplication, right? So that way I'm gonna use, but I have to use it in a specific way. Just give me a time. Okay. Yeah. So what I'll do is I'll write log of t2 by t1 is equal to r by cv into log of v1 by v2. Okay. Now this I can use here. R by cv is there. I have some A log B, right? So I can bring this term to the powers, right? Okay. So I can write log of T2 by T1 is equal to log of V1 by V2 power R by C. Okay, now it's very simple, people. What is so simple? Now, if I take anti-log on both sides, right? If I take anti-log on both sides, or in a very wrong way, how to tell it is, if I cancel log and log, absolute crap, right? So how you have to tell it is, I'm taking anti-log on both sides. Here I take anti-log, here I take anti-log. Log, I mean anti-log and log are inverse functions. So they're gonna cancel out each other. So taking anti-log. See, this derivation might come for your exam, and even the derivation for your isothermal reversible expansion might come. Okay, so this is a little important. So now how will I write? T2 by T1 is equal to V1 by V2 R by power R by C. Correct? Right? T2 by T2 is equal to V1 by V2 into power R by C. Correct? Okay. Right. Then how can I write is, now see, I'm going to give a new constant. So this R by CV, I'm going to write it as gamma minus 1. Okay, R by CV, I'm going to write it as gamma minus 1. And there is a reason for this, because you are going to derive relationships between, see, what you have here is temperature and volume. That's the only thing you have, right? So you are trying to get a relationship for temperature and volume for an adiabatic process, reversible adiabatic process. Now I'll be able to get it for a pressure and volume, pressure and temperature. All these things are possible for me, right? So R by CV is a little complex term, so I just make it into a smaller term called gamma. Okay, now this gamma is what is called as coefficient of thermal expansion. Am I right? Gamma is called coefficient of, yeah, correct. Coefficient of thermal expansion. Okay, now how will I be able to write the equation now in terms of gamma? I have I have T2 by T1 is equal to V2 by V1, the whole power gamma minus 1. Right? So now, again, how will I be able to rewrite it? I can have okay, I can just V2 power gamma minus 1, I can bring this side, and T1 this side. So how will I write? I have T1 V1 power gamma minus 1 is equal to T2 V2 power gamma minus 1. And if I had one more equation regarding T3, that will become T3 V3 power gamma minus 1. Right? So what you're seeing here, the temperature change and the volume change are going to be having a proportional, some kind of, how do you have PV is equal to constant? When I have PV is equal to constant, how I write? V2 is equal to P3, V3, so on and so forth. Now, instead of having just T and V or P and V, I just have a power, right? So now how will I be able to write the perfect equation? I'll be able to write it as T V power gamma minus 1 is the constant. This is the equation which you have to get. Okay, T V. There is no power for T. There is power for V. T V power gamma minus 1 is going to become constant. Okay, so anybody has any doubt on how I derived this?
Sir, I didn't understand how we got gamma, sir.
No, see, just remember R by CV is equal to gamma minus 1. That's it. That's what you need to remember. Okay, so R by CV is gamma minus 1. So what I have here, V1 by V2, the whole power R by CV. Now what did I say? R by CV is gamma minus 1. So that's it. Then I rearranged and then I got this. That's it.
Okay, sir.
Right. Okay, so everybody hopefully got, right? So this equation is very, very important. Now, right, now how am I going to use this equation in a problem? Right. Say they might ask you, now since I have my delta E and W to be equal, right? Since I have delta E and W to be equal, right, you cannot directly find the work done. Right? You cannot directly find the work done here. Right? What you have to do is, say for example, they might give you T1, they might give you V1, and they might give you V2. Right? So if then and they might ask you to find the work done during the adiabatic expansion. Again, I repeat the question. Right? So they will give you T1, they will give you V1, and they will give you V2. Right? And they ask you what is the work done during this process. Right? So what you have to do, you cannot directly find work done, but what you can find is, you can find directly is my delta E, because delta E is going to be equal to NCV del T. Right? So obviously what I need is just my T2 and T1. Right? And obviously I know three of them, only T2 is not known. Find T2 from this equation and substitute it here, and obviously that will be equal to my W also. Okay, so this is how problems will be asked. Is that okay? Right? So yeah, we are almost on the verge of, I mean, I would say 60% of the first part is over. Right? I would say 70% is over. I still have some 30% left about entropy and stuff. Okay, so what we do now is I think we are gonna have a problem solving, or I think we might even have quiz. What do you want? You want to do? Okay, I think we'll do problems. It's better. We have to do problems. Just give me a moment. Okay, right on the question paper. You have to have your notebooks with you. You have to solve it, right? Okay, a question. 8 grams of O2 gas. 8 grams of O2 gas at STP. 8 grams of O2 gas at STP is expanded to double its initial volume. Okay, again I repeat the question. I mean, 8 grams of O2 gas at STP is expanded to double its initial volume. Okay, now they're asking, what is the work done? What is the work done? So they have 8 grams of high oxygen gas at STP, and they say that the volume is getting doubled to its initial volume, and they're asking you to find the work done. And I want the answer in liter atmosphere. You will be really surprised at this question, right? Because you don't know the initial volume, you don't know the final volume, and you don't know the external pressure also. I know the formula. Formula is W is equal to minus P external del V, but all the clues are given in the question. How will you approach this problem, people? Any idea? So you have to find three things, at least two things. One is the pressure, external pressure. Second thing is about what is the initial volume. If you find the initial volume, obviously you can find the final volume because they were given the question that the final volume is double the initial volume. Okay, so tell me, how do you find the external pressure and the initial volume of the gas?
So since it's HTP, there'll be a value for it. Every gas will have a
Sorry.
constant value.
I don't understand what you're telling. What did you say?
Since O2 is in HTP, sir, so it'll have a like it occupies this law, no, sir,
Yeah.
for HTP.
Correct. That's how we have to approach the problem. So they have given you STP, standard temperature and pressure, right? So at standard temperature and pressure, if I have 1 mole of any gas from the mole concept, 1 mole of any gas will occupy a volume of
22.4 liters.
yes, right? So obviously 1 mole of any gas at STP will occupy a volume of 22.4 liters. But do I have 1 mole here?
No, sir.
Okay, so you have to understand that I don't have 1 mole, but I have only 8 grams of oxygen. So for 1 mole, 22.4 liters. So for this many moles, 8 divided by 32, oxygen gas's molecular mass would be 32. So 8 divided by 32 number of moles. What will be the volume? That will be the initial volume. Okay, fine. That is okay. What is the external pressure? What are the temperature? What is standard temperature and what is standard pressure? What is the value? Standard temperature value. How is it possible? Just now you wrote your midterm exams. Definitely mole concept would have been there in your chapters. Okay, I think I'm gonna pick. Who
So
should
it
I
said
pick?
0 degrees Celsius for temperature.
0 degrees Celsius. Yeah, 0 degrees Celsius is the standard temperature. Okay, what is standard pressure?
I'm not sure. Is it 180?
It is. Right. So people, like, you can understand how all the chapters are connected, right? If you didn't follow previous chapters, you might even understand whatever is happening. But when it comes to problem solving, or say when it comes to say very like in-depth concepts, you have to know all the other previous chapters. Okay, fine. So I think you would have gotten a good idea of how to do the problem, right? So everybody got it. Please give me a yes. Like everybody got how to know to do the problem. Okay, I take it as a no, right? Fine. So how do we solve this? I'll repeat, right? So they have given 8 grams of O2 at STP. First of all, like we look at the formula. I know W is minus P external del V. Okay, so pressure is not given, initial volume is not given, but they just told that the final volume is double the initial volume, and they have given me 8 grams of O2 gas. Correct, right? Fine. Now you have to do something to find the volumes, and you have to do something to find the pressures, right? So what you can understand is, if the gas is present at STP, right? So I know standard temperature is 0 degrees Celsius, standard pressure is 1 atm, right? Standard temperature is 0 degrees Celsius, standard pressure is 1 atm. So obviously this is what is my external pressure. There is no other pressure possible, right? Obviously the gas is expanding against the atmospheric pressure, or say the standard pressure of 1 atm. So this value we know, P external we got, right? Now we have to get so basically this would be V2 minus V1, and what I can find is V2 is 2V1, right? So it will basically be V1. So P external into V1 minus P external into V1 would have been the answer. So this is given in the question. The final volume is double the initial volume. That is given in the question, right? So now how do I find V1? It's very simple, right? Now I know, like at STP, 1 mole of any gas, right? 1 mole of any gas will occupy a volume of 22.4 liters, right? So for 1 mole of any gas, 22.4 liters, but I don't have 1 mole here. I just have 8 grams of oxygen. If I had 32 grams of oxygen, that is 1 mole, right? So I will be able to calculate 8 by 32 will be the number of moles. Number of moles formula is given mass by molecular mass. So if at all you don't remember, right? So it's what is that? 1 mole, number of moles is equal to given mass by molecular mass. So for 1 mole of a gas, it's going to be 22.4 liters. So 8 by 32 will become basically 0.25, 1 by 4, right? So this will also become 22 point, or else you can calculate x, right? So if you calculate, x will turn out to be 22.4 divided by 4. Okay, so 22.4 divided by 4 will become 11.2. 11.2 divided by 2 will become 5.56. Yeah, 5.6 approximately. Right? So 5.6 would have been my initial volume. Is it not? Right? So I have, again, I repeat, 1 mole of any gas will occupy a volume of 22.4 liters. Right? So how many moles of O2 gas I have? 8 divided by 32 moles of O2 gas I have, that turns out to be 0.25 moles. So for 0.25 moles, I just keep it as x cross multiply. Hope you know this method. Right? So you will be getting x as basically 22.4 divided by 4, which will be equal to 5.6 liters. Right? Now that's it. You got your volume, initial volume, and you got the equation also. We did all those calculations. We got minus P external into V1. And what is P external? P external value is 1 atmosphere, right? So what is the answer for this question? Minus 1 into 5.6 liter. So what is the answer? Minus 5.6 liter atmosphere would have been the answer for this question. I want everybody to unmute yourself and say yes if you understood, or not. If you want me to say, repeat again, you can tell that also. I want everybody in the class to do it. Go for it.
Repeat.
Sorry, you want me to repeat?
Yes, sir.
Okay, cool. So hope you have taken down the question. Question says 8 grams of O2 gas at STP has doubled its volume. They just asked me what is the work done. Okay, so for work done, W, I know the formula, which is equal to minus P external del V. No issues, right? So now, but nothing is given now. No information is directly given regarding P external or del V, right? But I will be able to find it out, right? So I know they have given standard temperature and pressure. The STP is given to you. So obviously, you know, standard temperature is 0 degrees Celsius. Standard pressure is 1 atm. Okay, so I have got the value of P external. Obviously, the gas is getting expanded against the pressure of 1 atm. Why 1 atm? Because they have given STP conditions. Right, standard pressure is 1 atm. Okay, now next what I have to find is about the V2 minus V1. Right, so what is del V? Del V will be basically the final volume minus initial volume. Right, so now in the question they have given, the volume is double the initial volume. So how can I write V2, that is the final volume, should be equal to 2 into V1. That is given in the question, right? 2 into V1 is given in the question because double the initial volume minus V1. So 2 V1 minus V1 will become just V1. So the overall work done will become W is equal to minus P external into V1. That's it. So all I have to do, I have found out the P external. I just have to find the volume. Again, the condition of STP is going to help you, right? So by definition of 1 mole, we have 3 definitions. One is regarding mass, one is regarding the number of particles, the another is regarding about your volume, right? So we know how to define all that. 1 mole of any gas will exactly 1 mole of any gas will 1 mole of any substance for that matter, right, will weigh exactly its molecular mass or atomic mass. That is the first definition. Second, 1 mole of any part, 1 mole of any substance will have Avogadro number of particles at STP. I know Avogadro number 6.023 10 to the power 23. And the third definition is this: 1 mole of any gas at STP will occupy a volume of 22.4 liters. Okay, 1 mole of any gas at STP will have a volume of 22.4 liters, right? So, but it is not 1 mole. The value given to me is not 1 mole. They have given me 8 grams of O2 gas, right? So first I have to find the number of moles. So number of moles would be given mass by molecular mass. Given mass is 8, molecular mass of oxygen gas is 2, because one oxygen atom atomic mass is 16, right? So 8 divided by 32 will become 0.5. So for 1 mole this much, for 0.5 how much, and that how much is basically going to be my 5.6 liters. Now going back to the formula, W, what I found is just minus P external into V1, right? So V1 I found out to be my 5.6 liters, and P external is 1 atm, and the answer would be minus 1 into 5.6 will become minus 5.6 liter atmosphere. Understood? Yes, who asks? Like someone asked me.
Oh, yes, sir. Understood.
Okay. What about others? Everybody should unmute and tell me.
Understood, sir.
Yes,
But
sir,
I
understood,
have a
sir.
doubt. If they ask for joules, we have to multiply into 1 or 1.3.
Exactly. So if the same question, if they ask you in joules, this is not the final answer. This into 101.3 would have been the answer. Yes. Good. Okay. Others, yes, please give me a yes.
Yes, sir.
Yes, sir, understood, sir.
Okay. I heard only 4 voices till now. Put it at least in the chat box. Divya, Mithun, who else is there? So many people are there. Rahul I think is there. Abhishek. Please unmute yourself and tell me whether you understood or not. Please give me a yes.
Yes, sir.
Okay. 5. How many people I have? Almost I have 9, 10 people here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 people I have. 4 more people are missing.
Yes, sir.
Okay. 6. 3 more. Okay. And guys, I wanted to speak to you. Like I got a complaint. Right? It's physics sir is telling, physics and math science, same sir is taking. There is literally no interaction. There is zero interaction between the class. If he asks you, nobody is opening their mouths. Okay, but when they asked me, is it happening in your class? I said no. They are actually engaging in. Almost all of them are engaging in the class. They're answering questions. They're asking doubts whenever I ask them something. So even though, like say, some of them don't answer, but still it's okay. Like it is not that bad as they tell me it is. I mean, for their subject, right? I really want to know what is the problem. Again, this is not going to go to them. I really want to understand what is the problem in unmuting yourself and talking. And I'm for I don't know. This is the first time I'm feeling this. Today's class was really not up to the mark, right? So maybe you don't know the answers, but that is perfectly all right with me. No, not knowing the answers is, I have never had a problem with that. But you not answering, not even telling anything, is really going to piss me off. You don't want to see that face, right? So from next class, I don't think I'll be asking you questions like commonly, right? Since you want to be treated as kids, I will treat you as kids, right? So from next class, I will be pointing fingers and I'll be calling names, and you are going to answer that question. And again, I don't mind if you're not going to give me the answer. But like this, if I ask you, everybody understood, and out of 9 people in the class, only 6 answers, and other 3, I don't want to pick names, right? So if it's really going to continue, right, you will see what will happen, right? So make sure when I ask you something, you are bound to answer me. Is that okay? Right? So because I am taking all the efforts, I am teaching you all the things in whatever the best way possible I know I can. So I expect you to reciprocate. Not only in my class, this has to happen in every subject, physics, math, chemistry. One more time, if I'm going to hear saying that nobody is responding, you will really face some serious consequences, right? So it's all about, why are we doing all this? Are we doing this to make sure that you feel bad? So by making sure that you give me wrong answers? Completely not. We are doing something. We are in a pandemic, right? If at all it was the class, I would have asked you, hey, get up and answer. So that was different, right? But here I will not be able to see you. We are doing an online session. Like, we are trying to make sure that you are going to get the best experience out of all this, right? But if you are not going to reciprocate, the faculty will lose interest. I'm telling you, the faculty will lose interest, and obviously he will not be able to give you all the information which is required, or say he will just give you the required information, but you will not even know that is the required information, right? So if the faculty loses interest, people, the sufferer is not going to be anyone else. It is definitely going to be you. Please keep that in mind, right? So next week in another, I'll give you 1 week's time. I know, like in physics and math classes, there are more number of people. Tell them also, right? If the faculty feels that you are not interacting, nobody is going to be at loss. It is you who's going to be at loss. Please keep that in mind, right? So I know here only two or three people answers. Nobody even opens their mouth. But I am keeping quiet because I'm getting something out, right? I want everybody to participate. See, again, how to put it? Again, I'm repeating. It really doesn't matter if you're gonna give me a wrong answer. Like, if it really doesn't matter. And if you're gonna think like, all my friends are there, my classmates are there, and they will think bad about me. Trust me, nobody does it. Nobody actually gives a damn about whether you're gonna give a right answer or wrong answer. It's all about whether you're participating, right? So it's within your right. You paid money, right? So you have taken so much efforts. You are waking up in the morning by 7 o'clock, early in the morning by 6:30 for you to get ready, right? Why is it that if you don't understand something, I know definitely at least one of you or two of you, or say 50% of you would have been there when certain concepts are going on that you did not understand. But I would ask you 10 times. 10 times I would have asked you, did you understand? Did you understand? Please give me a yes. Almost, at least it was before it was little okay. Everybody at least used to give me a yes. But I really don't know why this is deteriorating. Guys, if this is really going to continue, I will talk to your parents. Please keep that in mind. I have all their numbers. I will personally give them a call. I don't want excellent people to give them a call. I will give them a call if this is really going to continue. Hope everybody gets this, right? You do not want to see me angry. You really don't want to see me angry. Is it understood? Everybody can go next class. If this is really going to continue, I'm really sorry. That's all I can say, right? You can go get prepared for your school, and you can continue next class. Thank you. Bye bye.
Thank you, sir.